So examples using the binomial expansion, or in particular using the formula for the binomial expansion. Now, when it's a simple case like this, and there's no real coefficients to the terms within the brackets there, you don't need to write it out formally, especially if it only goes up to power 5 or so. You can quite easily write that down because you'll know the coefficients from Pascal's triangle, where the numbers are just formed from that cascade pattern that you would get in a bagatelle arrangement. So that one could fall either way, that one could fall either way, so there's two ways that something could arrive there, and then same again, that one could fall either way, both of them could fall either way, so there's three ways of arriving in this position and so on, like the ball's dropping down over the pins, 4, 1, and then 1, 5, 10, 5, 1, and so on for as far as you like. You tend to remember just that amount of it, so you could just rattle that straight off, and here it goes. So it would be, start at the top, x to the 5 plus 5, drop it down to 4, lift it up to 1, next one 10, drop it down to 3, lift it up to 2, next one 10, drop it down to 2, lift it up to 3, next one 5, drop it down to 1, lift it up to 4, and then finally just y to the 5. That's nice and easy. Another example, just like the other one, except this number 2 is going to interfere with the coefficients. They won't be nice and simple the way they were last time, just coming from those combinations. So maybe with this one I'll write it out formally. Right, so we'll start at 4, 4, 0, 4 and then 0, up to 1, down to 3, up to 1, 4, 2, down to 2, up to 2, 4, 3, down to 1, up to 3, 4, 4, x to the 0, up to 4. Right, so that's going to be 1 and that's 1, x to the 4. That's a 4, and that's a 2, x to 3. That's a 6, that's a 4, x to 2. That's a 4, that's an 8, x. And that's a 1, and that's a 1, so that's a 16. So it's going to be x to the 4, 8x cubed, 24x squared, 32x plus 16. Right. So there it is then. That's like the trickier one. The one thing you could do is you could take that 1 over x out. I'm not going to do that. You could take 1 over x out of the bracket, meaning that everything that's left inside will have to be x times bigger than it was, so 3x squared minus 1, and then since that was power 5, that will have to be power 5, since that's the number that have come out, and then you just have to do the expansion of this part, and then divide everything by x to the 5. But I want to practice using that formula. So for this one, I'll need a bit of space here because there's going to be 6 terms, and the terms aren't too small. So first of all, rattle through that pattern. Although, firstly, slowing it down a bit, that's going to be start at 5, so it'll be 5c0. Now the two terms are 3 to the x, that'll start at 5. And it's a negative 1 upon x, and that'll start at 0. And then the pattern just continue 1. So it's going down to 4 and up to 1. And then 2, so it'll be down to 3, but up to 2. And same with the other one, so that's going down. And the second one always carries that same bottom number 3, 3. So if this is 4, the following one's going to be 4. And then finally 5, 5, that'll be to the 0, and that'll be to the power 5. Right, so that's that bottom row there. So that's going to be 1. So 3 to the 5 is 243. That'll just be power 1. And there's an x to the 5 there. That's going to be 5 this time. 3 to the 4 is 81. That's a negative 1 now. X to the 4 over an x. Next one along will be the 10. 3 to the 10. 3 to the 3 is 27. That's a positive 1 this time. X cubed over just x. That's another 10. That's going to be 3 squared is 9. Negative 1 this time. X squared over x cubed. Back to 5 now. Just a 3 times a positive 1. X over x to the 4. Finally, 1 times just a 1 again, times a negative 1 odd power, so 1 over x to the 5. So what's that then? So that'll be 243 x to the 5 minus a 405 x to the 3 plus a 270, and that'll just be an x, minus a 90, but it'll be over an x, plus a 15, and that'll be over x cubed, and finally minus, and that'll be 1 over x to the 5. And that's that one done. With this one, I'll just increase that to 15. I'm certainly not going to write it all out. No. In a case like this, it's probably going to be the case that you'd be more interested in 1 or 2 of the particular terms. So what I'll do with this one, I'll say is For this one, I want to find the term that involves just x on its own. You notice that with this one here, it was power 5, so there's going to be 6 terms, but it starts with x to the 5 and it finishes with x to the negative 5. But that doesn't mean that there's 11 terms there. 11 because there's a 0 in the middle. No, there are certain missing terms. Only certain terms appear because those products cancel themselves out. Well, the same here. So this one, there's going to be 16 terms. One of them will be the term in x. How would you find it? Well, I'm not going to write them all out. That would just be daft. No, I'll identify it just by thinking of what the general term looks like. For this, if I were to write out the expansion, it would look like this. It would go from 0 to 15, but I'll put it in a concise form using the sigma notation of 15r times the first one to the power, starts at 15 and drops down, times the second one, starts at the 0 and climbs up, so that's the r that does the climbing up. That's what the general term looks like, forgetting the sigma part of it. So I could identify the term I need just by thinking of the power of x that I've got. I'll just take that one step further though. So that what I've got there is, the general term would actually be if I pull all the coefficients to the front. I've got 3 times 15 minus r, negative 1 to the power r for all the numerical parts, and that leaves the x's as 15 minus r for the index. There's an r underneath, so that's going to be 15 minus 2r. So I can identify the x term this way. The x term means that the 15 minus 2r must equal 1, x having power 1. Which means that if 15 minus 2r equals 1, that means that the 2r would equal 14, which means that the r should equal 7. So I want to identify the term where r equals 7. So it's just a case of putting that out. So the required term would be this. Don't need to write them all out. If I was writing them all out, I'd still be just halfway through writing them out before any evaluation. But I know which term I want to home in on. I want to home in on this term, the term that goes 15, 7 of 3 to the 15 take away 7 is 8, times negative 1 to the 7, and of course that'll be x to the 15 taken over 14 is 1, so x to the 1. That's the term I want. Now that's just a case of putting that into the calculator. So that would be 15c7, rather than taking Pascal's triangle and keeping on going through it until I got to the line 15 and then counting through it until I got to this part. Remember that wouldn't be the 7th one, because it starts 0 and then 1, 2, 3, 4, 5, 6, 7. No, just put it into a calculator. So that part comes to 6435, 3 to the power 8, 6561, negative 1 to the 7 is just negative 1, and that's overall times x. So the whole thing's negative. Multiplying them together, that's 4222035x. So the required term, the term in x, would be that one, without having to bother about any of the ones before it or any of the ones after it, if you just want to identify a particular term. So, one last example. What happens if inside the bracket there's more than 2 terms? Well, it's simple. You just have to group them into 2. It'd be the same if there was only 1 term in the bracket and you wanted to use it. If, for instance, you had something like this, you had 1.3 to the power 10. You could split that into 1 plus 3/10 to the power 10, if it was needed for some reason. Well, what I'm going to do with that is, I'll rewrite that round the other way and then group them. So I'm going to write this as x squared plus 2x plus 1 all to the power 3. There's the 2 types. It's just we usually have them grouped that way when x had a value less than 1, and written the other way when x has got a value greater than 1. So I'm just going to stick to this, the sort of usual algebraic way just now. I'm not talking about limits of series or anything. So, for that one, just go through the basic pattern. Only these are the 2 parts to it. So, rattling through for power 3. But first of all, that's going to start at 3, so it'll be 3c0, and the first term is x squared, and that's the one that's going to start at 3, and the second term is 2x plus 1, which will start at 0. Then, as before, that goes to 1, so that drops to 2, and that goes up to 1. Then it goes 3, 2, and that'll drop to 1, but that'll go up to 2, and then finally 3, 3, and that'll drop to 0, and the last term will climb up to 3. There. Now, that's fine, that's fine, that's fine, but that's not fine. And this one at the end isn't fine either, because these both need expanding. These are binomials in their own right, so they need to get multiplied out the next step. So what I've got here then, so that's just going to be 1. That's going to be x to the power 6, that'll just be a 1. That's a 3, that'll be x to the 4, and the bracket will stay as 2x plus 1. That'll be a 3, that'll be x squared. But now, what you've got here, now that bracket, that's 1, 2, 2, 1. It'll be squared, and then its own, then 1. So 4x squared, 2 times the 2x, that'll be 4x. And then the 1 will just stay as 1, plus 1. That's just a 1. Plus, that's a 1, and that's also just going to be power 0, it's just a 1. Now, power 3, that's going to go 1, 3, 3, 1. Going cubed, squared, on its own, 1. So first of all, cubed. So it'll be 8x cubed. Plus 3 times, now the squared of it, that's 4x squared. Then plus 3 times again, now just on its own, 2x, and then finally 1. Right, now multiplying that out, what have you got there? You've got x to the 6 plus 3 to 6, so that's 6x to the 5, plus 3x to the 4, plus that's going to be 12x to the 4, plus 12x cubed, plus 3x squared, plus that's just going to be 8x cubed, plus the 12x squared, plus the 6x, and then the 1. Right, tidying it up. Now, there's only one x to the 6, that's x to the 6. X to the 5, it's only x to the 5, 6x to the 5. X to the 4, so a couple of them, that'll make 15. X cubed, so a couple of them, that'll make 20. X squared, there's a couple of them, that'll make 15x squared. But there's only the one x, 6x, and plus 1. But there was a ploy here. That was just for the principle of what you would do in a general case like this. Notice that's a nice symmetrical answer. That's because what that actually was, if I take this one here, was if you've got x squared plus 2x plus 1 all to the power 3, that's the same as x plus 1 squared all to the power 3. That's just x plus 1 to the power 6, which is a very simple binomial because the ones won't make any difference. It's just going to be descending powers of x starting at 6 using the binomial coefficients, which you could get immediately from Pascal's triangle, which would be, I'll put these in first of all, so I've got an x to the 6, I've got an x to the 5, descending powers, I've got an x to the 4, I've got an x to the 3, I've got an x to the 2, and I've got an x, and finally I know there'll just be a 1 at the end. And what are these coefficients? It'll be the next line of Pascal's triangle. 1, add them 6, add them 15, add them 20, add them 15, add them 6, add them 1. Just what you've got before. Plus 6, plus 15, plus 20, plus 15, plus 6, plus 1. Because it was just an example. I just wanted to make sure it was nice and easy, you wouldn't make a mistake with it. It was just an example of how you would deal with an expression having more than 2 parts to it. You have to group them to create 2 parts. And it's probably simpler grouping the 2 smaller powers together rather than grouping the 2 higher ones. Right, this one's straightforward then. Now it's power 5. I could just write out power 5 from Pascal's triangle, but I think I'll set it out using these combinations. So since it's 5, it's going to start with 5c0. And the 2 terms are simply x, which will start at 5, and 2y, which will start at 0. Then that'll be 1, so that'll drop to 4, and that'll go up to 1. Then it'll be 5, 2, that'll drop to 3, that'll go up to 2. Then it'll be drop to 2, go up to the 3, then it'll be drop to 1, go up to the 4, and finally the 5, 5, drop to 0, and up to the 5. Coefficients, what have we got here? So that's going to be 1, coefficients first, that's 1, x to the 5, that's just a 1, that's 5, that's 2, that's x to the 4y, that's going to go to 10, that's going to be 4, that's x cubed, y squared, that's still going to be 10, that's going to be 8 now, x squared, y cubed, that's back to 5, that's going to be 16, that's x, y to the 4, that's going to be 1, that's going to be 32, that's going to disappear, so it's just going to be y to the 5. So what's that all together? That's going to be x to the 5, that's going to be 10, x to the 4, y, that's going to be 40, x cubed, y squared, that's going to be 80, x squared, y cubed, that's going to be 80 again, x, y to the 4, and 32, y to the 5. And there it is. Right, that's that one done. For the next one, Now there's no question of writing that out until I get to this term. I'll just identify the particular term from the pattern in that formula there. So if I was to write that expansion in its concise form, going from 0 to 12 of, and if that's 12 it would be 12r times the first part of the binomial, 3x, that would be 12 minus r, then the second part minus 4 over x squared, and that's the one that is power r. And then rewrite that just to separate the coefficients from the x's. So this expansion would be in its concise form 12cr of 3 to the power 12 minus r times negative 4 from that one to the power r times x to the power 12 minus r. There's another 2r underneath, so it'll be 12 minus 3r. That would be, every term would look like that, that's the general term. So if I want the term in 1 over x cubed, that means that I want the power 12 minus 3r to equal negative 3. So I want 3r, taking that way, reading that way, to equal 15. So I want r to equal 5. Which means the only term that I want to pick out of these 13 is the one where these r's are 5. So I'll just write that one out straight away. So that means the required term is this part here, not the sigma, because I don't want all of them, only want one of them, so it's just the actual term, would be 12, where r is 5, 3, when r is 5, that would be power 7, negative 4 to the power, well that was 5, and of course that's going to be 12 take away 15, so that is x to negative 3. Right, well I'm not going to keep on writing my triangle down to 12 and then counting along, because I may even count in the wrong amount, I may only go into the 5th one, when in fact it should be the 6th one. So what I'll do is, I'll put that into my calculator. Put that into the calculator. Right, 12c5. Now, if you didn't have a calculator, it would take a bit of time to do this calculation, it wouldn't be impossible. You can either get 12c5 by continuing that down to the 12th row, but remembering to count in the correct amount, because it starts 12c0, so 5 would actually be the 6th one in, or you could write it out as the 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2 times 1. But here with the calculator that made it easy. So that's 792, 3 to the power 7, 2187. It's quite a good big pattern actually, see that? 3 7s are 21, there's a 7 at the end and 1 7 makes 8. I don't know if that's significant. Negative 4 to the power 5, well that's going to be negative. And 4 to the power 5 is 1024. And then finally, x to negative 3. Multiplying that lot together, it's going to be negative, but I've done it here. It saves a lot of tedium. 177, 367, 4496. X to negative 3, or if you like, over x to the power 3, would be the required term. There. And finally, the third one here. Now, that's in the form where usually x would be greater than 1. So that I'll need to, if I want to use the binomial expansion, I'll need to split that into two parts. So the obvious thing to do there would be then to rewrite it as 3x squared plus x minus 1, putting those two together, because that would be a nice simple bracket to multiply out, much simpler than that bracket. Right, well, I'll just rattle through it again. I could go straight in with, oops, power 4. I could go straight in just with 14641. Well, not, because there's lots of other things to work out. So I'll put this down again. So it's power 4. So it's going to start at power 4, so before C0, the first term is 3x squared, which will start at 4. The next term is, is x minus 1, which will start at 0. Then, same as before, then it's going to be, that goes to 1, so that drops to 3, goes up to 1, that's 2, that drops to 2, that goes up to 2. Then 4, 3, that drops down to 1, and that goes up to 3, and then finally the 4, 4, and that'll just be power 0, and the final that'll be power 4. Right, next bit. So what have we got? So it's power 4, so we'll be using that line, 144. So that'll be 1, that'll be 3 to the 4 is 81, then you've got x squared to the power 4 is x to the 8, and the bracket will just be 1. That's going to come to 4, that'll be 27, that'll be x to the 6, and the bracket will stay the way it is, x minus 1. That'll be 6 now, that'll be 3 squared is 9, and that'll be x to the 4. Now this bracket, since the brackets are all x's and 1's, that means they're just going to go in descending powers of x. This is the 1, 2, 1 bracket. So it must be x squared minus 2x, and then plus the 1. The signs will alternate because of the negative 1. Right, so what's the next bit then? So that's going to be 4, that's going to be 3x squared. Now that's going to be the, oh, there's the 4 corrected now. So that's going to be the 1331. Right, so that'll just be x cubed plus minus the 3x squared plus the 3x minus the 1. And then that'll be back to the 1. That'll be 1 again, and that bracket will be the 1, 4, 6, 4, 1. Descending powers of x. So we'll start off with x to the power 4 minus alternating signs 4x cubed plus 6x squared minus 4x and then plus 1. So what's that then? So that's going to be 81x to the 8 plus 427s are 108x to the 7 and then minus the 108x to the 6 plus that'll be 54x to the 6 minus double it, 108x to the 5 back to 54x to the 4 plus that's 12x to the 5 minus 36x to the 4 plus 36x cubed minus 12x squared plus x to the 4 minus 4x cubed plus 6x squared minus 4x plus 1. So what's that then? So that's 81x to the 8 plus there's only 1x to the 7, 108x to the 7. Now there's 2x to the 6's, that'll be minus 54x to the 6. X to the 5's, there's 2 of them, 108 and the 12, that'll be minus 96x to the 5. There's 3x to the 4 is 55. And then take away 36, that'll be 19x to the 4. X cubed is a couple of them, that'll be 32x cubed. X squared is a couple of them, that's minus 6x squared. And then minus the 4x plus the 1. And there's that one done.